Okay, students. Now, till now, we have seen the concept of differentiation, how the questions of differentiation can be solved. I have shown you some questions, how to solve these questions. Before that, we have discussed limits also. Now the question is, why we are discussing so many things when we are discussing physics? Because these are the things of mathematics. Obviously, a natural curiosity will come in your mind that how these concepts are to be used in physics. How these things can be used in physics. Obviously, a natural question, a normal question may always arise in your mind. So let us now discuss that. How the questions can be solved. Right. And what is the use of these concepts in physics? Let us do first that. Look, here, concepts of limits and differentiation applied in physics. I have shown here two graphs. One is very clear, position time graph, all of you are aware. This is velocity time graph, all of you are aware. Let us see position time graph first. Let us consider an object is moving with the variable velocity. Okay? It is a graph for the variable velocity. At the instant of time t is equal to t, its position is x is equal to x. At the instant of time t is equal to t plus delta t, its position will be x plus delta x. Clear? Very clear it is. Now this point is A, this point is B. If I join AB, look, I drop a perpendicular from B and drop a perpendicular from A, which are meeting at the point C, as shown. What will happen? What will happen? Obviously, average velocity, I am talking about one-dimensional motion, speed and velocity will be equal. Average velocity V average should be equal. V average should be equal to, you will definitely write delta x by delta t, because whenever the object, I remind you once, whenever the object is moving with the variable velocity, okay, then the total displacement covered by total time taken is known as the average velocity. Average velocity delta x by delta t. Then if I take its limiting value, now I write limit delta x by delta t as delta t tends to 0. Look, I have taken its limiting value. I have taken the limiting value of the average velocity. Limiting value of average velocity. Can we write it like this? Then, I have told you before also, this may be written as according to mathematical concept. This may be written as dx by dt. And what is this? Look, delta t is tending to 0. Delta t tends to 0. It is almost coming to 0. Means what? Where? It has come almost here. At the instant of time t is equal to t. Approximately it is coming to this. At a particular instant it is coming. That's why it is known as only V. What is this called? Instantaneous. Okay? Instantaneous velocity. This I want to say. That means here you may write, you can write. What is instantaneous velocity? It is the limiting value of the average velocity. What is the instantaneous velocity? Instantaneous velocity is the limiting value of the average velocity when the time duration is negligibly small. When the time duration is negligibly small. Look here. I repeat. Hence, the instantaneous velocity is the limiting value of the average velocity when the time duration is negligibly small. Alright? In this way, look, by the help of the limits, I have changed the average value into the instantaneous value. Similarly, I can do the similar concept. Here also I can apply. I can apply it in case of the velocity time graph. How it will be done in case of the velocity time graph? Let us look at this. It is velocity time. Right? Velocity time graph, let us. In this, what does it say? The body is moving, the object is moving with the variable acceleration. The object is moving with the variable acceleration. Let us say that it is moving with the variable acceleration. Then what will happen in this case? At the instant of time t, its velocity is v is equal to v. At the instant of time t is equal to t plus delta t, it's increasing, so it will be v plus delta v. Then what will be the average acceleration? A average. How much it will be? It will be delta v by delta t. Exactly in the similar way. For that, what we have to do? PQ will be joined. From here I have dropped a perpendicular. This is also a perpendicular. I write this. That means, what is this? It is obviously QR by PR. Just like this, it is equal to BC by AC, isn't it? And again, here I write again limit of delta V by delta T as delta T tends to 0 will be written as, is it dV by dt? Will it be written as dV by dt? Okay, and dV by dt is equal to A. What is this called? It is called instantaneous acceleration. Then how can we define this instantaneous acceleration? Instantaneous acceleration, okay, instantaneous acceleration can be said to be the limiting value of the average acceleration. It is the limiting value of the average acceleration when the time duration is negligibly small. That means, in making the average velocity, in converting the average velocity to instantaneous velocity or average acceleration into instantaneous acceleration, we use this concept. Alright? We use this concept. I hope all of you got it. So finally, where we are coming, we got V is equal to, look, we have seen V average is equal to delta x by delta t, and simply V is equal to dx by dt. Isn't it? From here, average value is delta x by delta t and instantaneous value is dx by dt. Similarly, V average value is delta, sorry, it is V. Delta x by delta t. Just a minute. A average is equal to, it will be delta V by delta t and only acceleration is dv by dt. Isn't it? This we have got. Look, are we getting this? V average is delta x by delta t. Instantaneous is this. Instantaneous is always taken in the differential form. Instantaneous value is always taken as the differential form. Alright. So, for example, I give you an example in the form of the numerical. Okay, numerical. The question is, a particle is moving with the uniform acceleration. Just listen to the question. A particle is moving with the uniform acceleration. Follow me. Okay? And its displacement is given by s is equal to 10 into t plus 49t square. Okay? At the instant of time t, its displacement is given by this formula. What you have to determine? You have to determine its initial velocity. Okay? I have to determine its initial velocity. How much is the initial velocity? Let us see how much is the initial velocity. V is equal to ds by dt. right? d by dt of 10t plus 49t square. Agreed? Then how much you are getting? Will it be only 10, dt by dt is 1, and will it be 2 into, I write 49 into 2t? Then can I write 10 plus 98t? Okay. And what is initial velocity? When initial velocity will be taken? At t is equal to 0. V should be how much? 10 plus 0 means only 10. Look, when it will be said to determine initial velocity, will it be like this? I hope all of you got it. Initial velocity, when it will be set, t must be equal to 0 and this. Okay, so this way you can determine. And suppose you have to find out the acceleration, acceleration you have to determine. Then a is equal to simply dv by dt, d by dt of 10 plus 98t, isn't it? 10 plus 98t. It is, sorry, I think in the question there was some mistake. It was 4.9. It is also 4.9. Here also 4.9. Here 9.8. Because 9. Here otherwise it will, the value will come out to be here. It is 0 plus. It is 9.8. So it will be simply 9.8. Isn't it? A is equal to 9.8. Please make the correction in the question. 10 plus 4.9 t square. What is the initial velocity and what is the acceleration? We have determined both the things. I hope once you will go through it, I will upload some questions related to differentiation also. You can try those questions. Right? In case of any problem, you may ask your query. Okay?